All right, hi guys. Somebody asked if I would do number 17 on the worksheet, the verifying trig identities, and really these can be really difficult until you see the trick. So 17 sine of theta over 1 minus the cosine of theta plus 1 minus the cosine of theta over sine equals 2 cosecant of theta. So there are lots of different ways that you can try to do these. Whenever you see something like this, it might be a good idea to use conjugates. Also, whenever you have two different fractions, it might be a good idea to find a common denominator and then solve. I'll show both ways, and maybe they'll work, I don't know. Sometimes I run into a dead end when I try these. So I have a conjugate, 1 minus the cosine of theta. So I'm going to multiply by 1 plus the cosine of theta. And I'm actually going to quit using the thetas because they're all thetas. So now I won't use any of those thetas. So the bottom turns into 1 minus cosine squared. And the top, oh, that was a bad idea. 1 minus cosine squared. And the numerator is sine plus sine cosine. And 1 minus the cosine over sine is equal to 2 cosecant. Well, I know that 1 minus cosine squared is sine squared. And for a common denominator, I can put sine on the other side. So my denominator is now sine squared, and my numerator is sine plus sine cosine plus sine from here minus sine cosine. So sine cosine cancels sine cosine, and I end up with 2 sine over sine squared. So the sine cancels the sine squared, and 2 over sine is 2 cosecant. So we're done. Well, I ended up using common denominators anyway, so I'm not sure what would happen if I tried common denominators. That's too slow. Let me just see if there's a quick solution using common denominators. It may or may not work. So this side would need a sine over sine, and this side would need a 1 minus cosine over 1 minus cosine. So that gives me sine squared over sine times 1 minus cosine plus 1 minus 2 cosine plus cosine squared over sine times 1 minus cosine. So now I can put all of that over sine times 1 minus cosine. So sine squared and cosine squared makes 1. So 1 plus 1, so 2, minus 2 cosine over sine times 1 minus cosine. Oh, look at that, it worked. Pull out a 2, 1 minus cosine, and the 1 minus cosine cancels 1 minus cosine, and I get 2 over sine, which is 2 cosecant. So it worked both ways, and there are probably more ways to do it, but those are the two that come to my mind. All right, the other one I believe was 22. 1 plus sine over sine equals cotangent squared over cosecant minus 1. Now, it doesn't matter what side we attack, but I probably want to do the more complicated side. So I'll mess with this one over here. And there are lots of different ways. I don't know what just happened. Christy's in here laughing at me because I'm talking to myself. Okay. She's probably correcting my math. So a couple different things. We have a fraction in cotangents and cosecants, so we could convert everything to sine and cosines. We do have half a conjugate in the denominator, so we could try that. We also could just, well, one of those two should work. So let's convert to sine and cosines and see what happens. So cosine squared over sine squared divided by 1 over sine minus 1. So I have a fraction in the numerator and I have a fraction and a whole number in the denominator, so I need to turn the denominator into a fraction. So we need a common denominator, sine and sine, and that turns into 1 minus sine over the sine, and then we have cosine squared and sine squared. Now I invert the denominator and multiply. So the sine cancels the squared, and I now have cosine squared over sine times 1 minus sine. And if you look at what we want sine and we want 1 plus sine. So I'm on my way. I have part of that. I have sine here, and then cosine squared is 1 minus sine squared. So if I convert cosine squared into 1 minus sine squared, this is a difference of perfect squares. It's 1 plus sine, and 1 minus sine. So the 1 minus signs cancel, and then I have 1 plus sine and sine. So that worked. Okay, let's try it a different way, because we're just building your toolbox. The more tools you have in your toolbox, the easier calculus is going to be. What was it again? Cotangent squared over cosecant minus 1. Let's go straight for conjugates and see if that ends up being a little bit easier. So the conjugate here is cosecant plus 1. Cosecant plus 1. Oh, this is probably going to be really easy. I did it again. Gotta be careful not to touch the toolbar. All right, so the denominator, difference of perfect squares. Denominator gives me cosecant squared minus 1. And the numerator is going to be cotangent squared cosecant plus cotangent squared. Well, this is cotangent squared, I think. I better look. Yes, cosecant squared minus 1 is cotangent squared. So I get cotangent squared cosecant plus cotangent squared over cotangent squared. I'm going to pull a cotangent out of that, a cotangent squared, and I get cosecant plus 1, and that's over cotangent squared. So cotangent squared kills cotangent squared, and I get cosecant plus 1. Did I mess something up? I don't think so. Well, I want that to to be equal to 1 plus sine over sine. So take cosecant plus 1, and I'm going to put a sign underneath it because I want it to equal that. But in order for that to remain equal, I have to do the same thing in the top. And now I get cosecant sine plus sine over sine. And cosecant and sine are reciprocals of each other, so that turns into 1. And I have 1 plus sine over sine. So either one of those two ways works. If you have more questions, let me know. I'm usually here in the afternoon. I can record a video and send it to you guys. But so far, you guys are doing quite well. Keep up the good work.